Good morning. How are we doing today? I appreciate the opportunity to be here and speak with you. And thank you for inviting me to your country in this conference. Where is it? So my name is Michael Lotas. I'm the Chief Cybersecurity Architect for our group. I'm also the Director for International Cybersecurity Services. I work for General Dynamics. We're a $30 billion per year defense contractor. We actually have our fingers in defense, commercial, product, services. So it's a very broad spectrum program. My particular group is focused on advanced threat defense. We've got leading edge network-based advanced threat defense products. We've got one of the more experienced teams in the industry. We've done some of the largest intrusions, and I have a separate speech to discuss some of that. But on the commercial side, we have worked some of the largest intrusions in history. Part of our heritage, our group actually are the ones who defined the term advanced persistent threat, and we were the first ones to identify advanced persistent threat actors. So my group has unparalleled expertise in national defense cyber warfare. We've completed over 3,500 cases. As of 2009, for the US government, we had approximately 50% of all their cybersecurity business. On the commercial side, we'd worked over half of the large intrusions, including TJX, on the PCI data side. So one of the things I wanted to do, and I apologize if I'm leaning or turning, I'm used to actually walking when I talk, so this is a little different for me. One of the things I want to do is just at a very high level give you some key talking points to remember as we're going through. I don't have that many slides. I'd like for this to be interactive if possible. We're here for you, so if you have any questions, you want to stop me at any time, just go ahead and speak up. So when we're talking incident response and the corresponding technologies, one of the things to keep in mind is that incident response actually starts today. So it's an operational, it's an ongoing, even if you don't believe you're currently under an attack or you're not performing incident response, you're preparing for it today. And it's an ongoing, continuously improving process, so you're never actually done with an incident response or incident response. You should get in the mindset that you are always performing incident response, security engineering, continuous improvement. One of the things that's kind of our mantra is defense in depth or even operations in depth. A few years ago, the NSA came out with what they call their defense in depth model, which was people, process, and technology. And we've adopted that as a defense contractor. We borrowed it from them. And we've adopted that in pretty much everything that we do for cybersecurity, whether it's incident response, proactive services, reactive services, it does not matter. When we say people, and you can see at the bottom, people are the most valuable tool in your toolbox. People are key to any IT organization. You can have all the technology that you want, but without the proper people to implement it, the proper people to run it, it's meaningless. Without the processes to define how you're going to utilize that technology and how you're going to utilize the IT assets, all the technology in the world is meaningless as well. And the technology itself, we're a technology vendor, but I'm not here to sell you any technology, so one of the things that, as a technology vendor, we're continuously coming up with buzzwords, changing the technology, improving it, modeling it for sales, performance, customer support. But in reality, technology hasn't changed all that much. What we're really trying to do with each iteration of technology is get a little more granular with the rule sets that we can apply, reduce the human element, and automate the operations of the technology. But a lot of the technology that we're putting in place now was in place 10, 15 years ago in many government organizations. Multi-level security, for example. If we implemented that across the commercial sectors or the government sectors, oil industry, it would resolve many of the issues that we're currently having, and that's old technology. As we talk about incident response, and everyone has an opinion, but the way that we handle incident response, we use a model of distrust. When we start an incident response, and this is the active engagement, we trust nothing and verify everything. And that includes any existing IT infrastructure, personnel, power, networking. We absolutely trust nothing. We bring our own kit with us that includes the entire SOC and all the tools, and we'll get into that later on. As we run through an incident response, we work towards conditional trust of the personnel, the infrastructure, the IT. But we never fully trust anything. And that's part of our operational model. We never trust anything in there. We're always validating, we're always verifying. One of the things that as you're doing incident response, and as I do security engineering for an enterprise, I'm really trying to be product or technology agnostic. I deal with capabilities, not specific products. And I'm a vendor, I have partners. A lot of my partners are here. But I deal with capabilities, not specific products. We also try to deal in layered defenses. And there's a difference between a defense in depth with each people, process, technology, and a layered defense, where you're taking multiple layers of technological appliances, tools, solution sets, and putting them in line. Quick example, I used to work with the United States government's premier penetration testing organization. They evaluated everyone, got in on everyone. I had no budget to defend a small network, so I used a layered defense approach where I took free open source tools and I layered them about 20 deep. I gave the architecture to this group and said, go ahead, you've pen tested everyone, all the big 3 letters, see what you can do to get in, and they could not get in. So I had a budget of about $1,000, they couldn't get in, but they were getting in on companies that had spent millions, sometimes hundreds of millions of dollars. Can't tell if you guys can actually read that or not. So as you can see, as you can see up here, we've got a loop going through. In the upper left-hand side, we've got prediction. And the blue boxes are people, process, technology. So we try to utilize the people, process, technology, defense in depth, or operations in depth model in every aspect of our continuous monitoring and analytics process flow. So we have prediction, where we're actually using threat intelligence. Prevention, where we're securing the network environment with the current people, processes, technology. Detection, situation awareness and visibility are key. And then the actual response, which then feeds back into the prediction. But this is a circle, it never actually ends. So this year, I've done about 4 large incident responses, including one for a Fortune 120 company that I just left to actually come up here. We've also gone back and with some of our early customers from almost a decade ago, I just went and did a security engineering assessment last spring. So we've been partners with them for 9 years, and we're still going through this process with them to ensure that they are secure, their technology is in place. When we did incident response for them, the end goal was to take them 5 years ahead of everyone else in their industry. We did that, and then we're continuously monitoring it ever since to ensure that they're staying 5 years ahead of the other groups in the industry. The industry is retail. Target is one of the largest companies now that is in the news for getting hacked. Our customer was actually immune to the vector that was used for the Target hack because we had hardened them against that specific vector 7 or 8 years ago. So as we're talking about capabilities versus specific technology and products, and this is on the operations side as we're going through, you can see that we feed this into kind of a defense in depth, multiple concentric rings. In the middle, we have data security, because any incident is going to be about data. In the end, if they're coming into your enterprise, they're hacking you, they're trying to gain access to your data. The end goal of what they're trying to do with the data can vary. CISSP has their CIA, confidentiality, integrity, availability of data. We try to protect all of that. So we're trying to protect it from being exfiltrated, so you lose your IP, from being modified, or from you having it being denied access. One step up is host-based security, whether it's operations or incident response. We're always looking at the hosts. The internal network, the perimeter, physical security, and then the policies, process, and situational awareness are the overarching wrapper around all of that. One of the things that we actually provide is services, and we've tied this in, and each of these services has some component of people, process, and technology. And this is something that if you're setting up an incident response capability for your agency, for your company, you would probably want to have these capabilities in there as well. Open source intelligence monitoring for the prediction. That's pretty important. If you're not a government agency, it doesn't have to break the bank to do that. You can actually have 2 or 3 analysts doing that work. The security stack we use for that is very simple. We have a Linux box. We run a anonymized proxy on there. We run a virtualized system on top of that. We run Windows in that virtualized system. On the Windows box, we're running a sandbox. In the sandbox, we run Tor browser. So there's multiple layers. Some of the folks laugh and say it's the inception of surfing the web. But it provides us security so we can go out and hit websites that we don't want to have attribution back to us. In incident response, that capability is critical. One of the things they look for, they being the high-level intruders, is activity from your IP block to theirs. So if they have a command and control software or system beaconing out to a set of IPs, it's going out with a very specifically formatted message. It's hitting a specific directory on that IP address. If you start doing research and hitting that IP address or that domain from your standard IP addresses, they're going to know something's up, and they'll modify, and they often have secondary or tertiary methods and avenues back into your enterprise. So as you're doing incident response, you always want to have a secure, anonymized, non-attributable way to do research, search the web, and go after the bad guys. On the prevention side, we have cybersecurity engineering assessment, security controls assessment. The engineering assessment is basically looking at the entire holistic design of your enterprise, and we're looking at that from an engineering standpoint. Data security, data characterization, system characterization, network characterization. You can't protect what you don't understand. If you don't have a good network diagram, you don't know where to place your technology, you don't know how to enforce your policies. One of the things that's a truism is that the intruders, when they get on your enterprise, will have an accurate network diagram. They will have a data classification and characterization diagram of your enterprise. They will know what the systems are. They may even go into your systems and patch them for you to make sure that their software works better. We've seen them go in and patch and upgrade a test environment so that they could model their malware in a controlled environment in your enterprise or in their enterprise. Security controls assessment is where you're going in and basically doing a readiness assessment of your security controls. Breach indicator assessment, you're looking for indicators of compromise internal to the network, and this is really where the model of distrust comes into place. You have your existing infrastructure. When we do a breach indicator assessment, we're coming in with a portable kit and an additional set, a known good set of hardware. Often an intruder who's been in an environment for a long period of time will come in and modify your hardware, your security controls. They'll take your IDS, IPS sensors out of your switches. They'll modify the rule sets on your firewalls. They'll take out rules in the IDSs, IPSs. So we're bringing in a known good set of hardware to ensure that the results we're getting are verifiable, validated. And then incident response readiness review, that's where we're actually going through and doing a pretend or a simulated incident response. So now when we said we have, or I said I had categories rather than specific products, when we're running an incident response, this is a very, very high level. I can actually drill down 3 or 4 levels on each of these boxes, but it's a very high level view of how we do incident response. If you look on the left-hand side, the red box, Security Operations Monitoring Team, the very first line there says CyberSOC. That's actually a kit that we've built. We have 2 different versions. One of them is man-portable, fits in an overhead luggage bin on an airplane. One of them we have to actually ship. It's a small, portable, ruggedized, mil-spec rack mount system. We send that out there because we don't trust anything, and we use that as our known good that we're expanding out. So we have a hard and crunchy CyberSOC. Eventually we'll have a hard and crunchy enterprise, and then the shell. Along with that, we're sending out seasoned analysts. Now in the CyberSOC and the analysts, this is agnostic. We're using a SIM that can take in feeds from almost any source. And it's an open source, or we have access to the code. They're a partner of ours. So we have programmers we send out as well to write hooks into whatever other security tools and appliances that a customer will have on site. In the CyberSOC, we'll have a SIM. We have an intrusion detection prevention system. We have full packet capture. We have data analytics. We have knowledge management, and knowledge management is really key when you're doing incident response. You need to track what's going on at every step of your incident response. We use a wiki. It's open source, freely available. Some other folks, there's a plethora of tools out there that you can use. Other people like to use cloud-based encrypted solution sets so you can have folks on site collaborating with people off site. The investigative support, IOC ingestion, situational awareness. Situational awareness is slightly different than the SIM. That's situational awareness of the ongoing enterprise. When we're doing that, we're looking at your routers, switches, logs from your servers. This is not just incident response in terms of events that we're seeing in a firewall and IPS. We're looking at the holistic enterprise, user activity. We're trying to get a baseline characterization. IOC ingestion. As we're going through, this is the investigative side, we break apart the malware, We also use our threat intel resources to get IOCs for these particular bad actors and bring them into our security operations monitoring team. The last one, and what we do with incident response, is SOC building and network validation. When we're building a SOC, and that's why we're saying capabilities, not products, we come in with a suite of tools. We have our own firewalls. They're actually Cisco ASAs, but that's what we happen to use. We have our own SIM. When we're on site, we build a SOC or help a customer build a SOC using their existing infrastructure because we don't care what the technology is. It's a capability. If you're doing log analytics, it doesn't matter what you're using for log analytics. It's a capability. If we need to enhance that capability, we'll help you enhance it. But what this is really getting down to is it doesn't matter what the technology is. It's how you implement the technology. That is the key. I've seen customers spend hundreds of millions of dollars, as I said before, on a next generation suite of hardware, proprietary, locked in, they never used it. We've gone in with our little bitty kit, which is man portable, and secured an entire enterprise. So it's implementation. When you're doing incident response, investigation is extremely important. The capabilities that you need, it varies based on your environment, but at a minimum, you're going to need some sort of reverse engineering capability. If there's a piece of malware, we use IDAPRO, but you're going to need to be able to reverse engineer, work on the malware. You're going to need to be able to do artifact collection, tracking, management. That's actually extremely important if law enforcement is going to be involved. Now, for a government agency, it may not be as important, but if you're ever going to testify, and all of our folks are able to testify, you have to have some sort of process for artifact collection, evidence custodian, evidence tracking, and management. IOC triage, deep dive analysis. When we say deep dive analysis and forensics, we're doing forensics on images of systems, so we have to use EnCase or some other tool to capture the image forensically. We're also doing analysis on data analytics. One of my favorite tools, I've used it for years, is Splunk. A lot of people don't think of using Splunk for incident response. We use multiple versions of Splunk, multiple installations when we're doing incident response. Every analyst has Splunk on their laptop. We set up a directory, you drop everything in there, it's indexed, all of your notes, everything you're working on. For large-scale data analytics, we're using Splunk on our portable system, 256 gigs of RAM, a few terabytes of solid-state drive and 24 cores. We can burn through terabytes of data in a couple hours. We're also doing a damage assessment, and this is key. It's not necessarily technology, but we're looking at what did the intruders get when they got inside? How did it impact your environment? How did it impact your IP, your long-term branding? And we get into more on that in a separate speech that we have. On the remediation team, perimeter defenses, internal enhancement, we put in on the perimeter, we're enhancing your existing perimeter defenses. If we need to go purchase more, we will. But we're enhancing your existing technology. Firewalls, intrusion prevention systems, intrusion detection systems. Internal enhancement, we're looking at host-based security. Bit9 is one of our favorite partners with Carbon Black. Patching. And I get into that later on, but most of the hacks that are happening now are just due to unpatched systems. Security hardening, segmentation of the enterprise, that goes back to the security engineering. Access management of your data and encryption of your data. If your data is encrypted, it doesn't matter if it leaves your enterprise. We use a number of different tools to do data encryption. And I am just about out of time. So the key takeaways, let's scroll back up again. key takeaways here. The technologies that you use don't really matter. It's the processes and the people that you use that are key. Your incident response, it's an ongoing effort. So the tools and technologies that you have in your enterprise today, that's what you have to fight the battle. We're in a war right now with these hackers. Fight the battle continuously. They're not iterating. Defense in depth or operations in depth, people, process, technology for operations as well as your defense, a model of distrust, and then try to be agnostic on technology. Look for capabilities. And questions? Anyone? All right. Thank you very much.